For the last question on page 93, it is combined with your knowledge on graphs as well. Let us look at this question. Part 1 reads, the line y equals to x minus 2 intersects the curve y squared equals to x plus 10 at points A and B. The line and the curve intersecting at point A and point B. So something about overlapping, something about intersecting, something about simultaneous equation. The question wants you to find the coordinates of M such that M is a midpoint of AB. So in order to find M, we must first know what is A, what is B, so that we can then calculate what is the midpoint. To find A and B, we know that the A and B are the actually points of intersection of the curve and the line. So let's solve this simultaneously. So I have my first equation, the line is equals to x minus 2. Oops, what happened to my minus? All right, x minus 2. And then the other equation reads y squared equals to x plus 10. All right, if I sub my 1 into 2, I will get x minus 2 squared is equals to x plus 10, which means it's x squared minus, not plus, x squared minus 4x plus 4 equals to x plus 10. And that gives me x squared minus 5x minus 6 equals to 0. If I do my factorization, x squared negative 6 negative 5x. X squared has to be a x times x. In order to get a 5, it could be a 6, 1, it could be a 3, 2 combination. Let's go with this one will give me, which one should I use? 3, 2, or let's try a 6, 1. 6, 1. So this will give me negative, this will be negative 6x, this will give me positive x to give me negative 5x. Okay, good. So I have x minus 6, x plus 1 equals to 0. Meaning x is equals to 6 or x equals to negative 1. And when x equals to 6, the corresponding y will be 6 minus 2, that's 4. The corresponding x will be the x equals to negative 1, so the corresponding y for this one will be negative 3. All right, it doesn't matter which is A, which is B, because ultimately we know that we have one pair of coordinates known as 6, 4, another pair, this one is 6, 4, this one is negative 1, negative 3. So I will then therefore find the midpoint of AB, also known as M in this case, will be 6 plus negative 1 over 2 and 4 plus negative 3, this whole thing over 2. That's 5 over 2. And this one, 4 minus 1, and give you half. Okay? Now we have solved part 1. Let's go to part 2 again. Let me go back to the question. The question reads, D is the point 4, negative 4 such that it is a midpoint of CM. Find the coordinates of C. D is the midpoint, CM is the line segment. So since I do not know what is C, I'm going to use let C be XY. All right, I know that the midpoint of CM, meaning let me shrink it a little bit so that we can see the value of M. Okay, I know that if I take X plus 5 over 2 and I divide by 2, y plus half and I divide by 2, this is equivalent to 4, negative 4, the midpoint. All right, so the conclusion I can draw is I have x plus 5 over 2 over 2 is equals to 4 for the x coordinate. X plus 5 over 2 equals to 8 if I multiply both sides by 2. Then now if I multiply by 2 throughout, I get 2x plus 5 is equals to 16. Right? So 2x is equals to 11, x is equals to 11 over 2. Earlier, we have y plus half over 2 is equals to negative 4. I know that y plus half is equals to negative 8. 2y plus 1 equals to negative 16. 2y equals to negative 17. Meaning y is equals to negative 17 over 2. So therefore, your C is 11 over 2, negative 17 over 2. Okay, so midpoint isn't too difficult as long as you know the formula, just like for length, just like for gradient. Let's move on to the next part of the module then. Sorry, next part of the chapter in a new module. See you!